So yesterday we used equivalent fractions. Yesterday we used models to find equivalent fractions. Let's pretend that you guys each have cards. Six of you have a blue card. That includes you, sorry. 4 of you have a red card. And 2 of you have a yellow card. What fraction of students have blue cards? What's the fraction? So tell me the fraction, then I'm going to say, okay, thanks for telling me the fraction. What's the numerator and what's the denominator? Nobody should be touching their bag right now. Nobody should be touching their bag right now. What fraction of students have blue cards? I only see 4 hands up. Now everybody should be able to figure this out. This is a first and second grade skill right now. So there's this many students. 6 of them have blue cards, 4 have red cards, 2 have yellow cards. What fraction of students have blue cards? Ethan?
6.
What fraction? 6 is a whole number, not a fraction. Fraction is a part of a whole. Out of the whole class is here. What fraction of the whole class has blue cards? Carla? 6 12ths. Now for those of the class that cannot add, how did you figure out it was 6 12ths? How did you figure out that the denominator was 12?
Well, I knew that 6 and plus something would add to get 10.
Okay, so 6 plus what is 10?
4.
So 6 plus 4 is 10, but is that all the students?
No.
Then what did we have to do?
Plus 2 equals 12.
So Carla did what a first or second grader would do. So come on, that means you need to be thinking. And she said, okay, she knew the fraction of cards. She knew that 6 students had blue cards. So that means 6 out of the whole class had blue cards. So she was like, okay, how do I find out how many are in the class? Well, Miss Folas said this was the whole class. This was our class. So that means I needed to add the 6 students with blue cards to the 4 students with red cards, which is 10. And then add the 2 students with yellow cards, which is 12. So there's 12 total students. 6 of them have blue cards, so that means 6 out of the 12 students have blue cards. Okay, 6 12ths of the class has blue cards. So let's model 6 12ths. Class, how many 1/12 pieces do you need to represent 6 12ths? Class? 6. Okay, next we're going to find equivalent fractions. So what that means is that we need to figure out, okay, what's another denominator I can use that I'm going to be able to find, that I'm probably going to be able to find an equivalent fraction? Well, I said first, look for the multiples. What's the first multiple of 12? Zari.
24.
24. Do we have fraction tiles with the denominator of 24?
No.
No. So let's try factors of 12. What is a factor of 12 that we do have fraction tiles with that as a denominator? Zadie.
6.
6. So let's start matching up 1/6 tiles. 1 is not equal. 2 is not equal. But 3 is equal. So that means what fraction is equivalent to 6/12? Michaela? 3/6. Now, is there something we could have done more quickly to 6/12 that would have taken less time than finding all these fraction tiles? Colin?
Yes.
Yes. What could we have done that would have taken less time than finding all these fraction tiles?
We could have divided 6,
So we could have divided the
numerator,
and the
denominator,
each by.
2.
We could have divided the numerator and the denominator each by 2. Those are basic facts, right? Those are really easy basic facts. And that would have taken like 3 seconds, maybe 5, instead of having to search through our bag for our fraction tiles. If we divide 6 by 2, do we get 3? Class?
Yes.
If we divide 12 by 2, do we get 6?
Yes.
Yes! So that's what we're going to be doing today. We're going to be figuring out, okay, can we multiply or divide our numerator and our denominator each by something to get that other fraction? If we can, then they are what type of fractions? Lena? Equivalent fractions. Okay. So everyone, let's look at example 1. Okay. Please read the sentence at the top, Zari. Everybody follow along.
You can use multiplication to write a fraction with a denominator of 10 as an equivalent fraction with a denominator of 100.
So what that means is you start with a denominator of 10 and you can find an equivalent fraction with a denominator of 100 by doing what? Carla?
Multiplication.
Multiplication?
And the numerator.
Nope. Can we get a bigger number by dividing? No. So continue. Multiplication by what? Come on, guys. I can start with the denominator of 10 and find an equivalent fraction with a denominator of 100 by, Zari?
Tens.
By tens? What do you mean by tens? You need to tell me the whole thing. You can't just tell me by multiplying, okay? You can't just tell me tens, okay? What about tens? What about multiplying? Colin?
You can multiply by 10.
By multiplying by 10. Come on, guys. This is easy. If you are not thinking, you're just going to sit there like, what? If we start with 10 and we end up with 100, what did we do? Colin?
You multiply by 10.
We multiplied by 10. That means if I multiply the denominator by 10, what do I have to do to the numerator to get an equivalent fraction?
You have to multiply by 10.
I have to multiply by 10. So if I look at my original denominator and then I look at my equivalent fraction denominator, I have to figure out, okay, what did I do to the first one to get the second one? Here, I multiplied my first denominator by 10 to get my second denominator 100. That means to get an equivalent fraction, I have to multiply my first numerator by 10 to get my second numerator. Because when you're finding equivalent fractions, can you multiply the numerator and the denominator by something different? Can you? Why? How do you know? How do you know? Zadie?
Because if you multiply it by
There's an exact way you know. Find it. There's an exact way you know that you can't multiply your numerator by anything different. Carla?
The way you know is that you multiply the denominator and the denominator by the same number.
Okay, but read it exactly as it appears, because you said the same word twice.
Multiply the denominator.
Numerator, that's not an O.
Numerator and denominator by the same number.
Carla, can you go around and point to where that is in everybody's book? Because nobody else was able to find it, and some people were looking like 3 lessons back. I don't know why. So point to it in everybody's book. If they're not on the right page, turn their book to the right page. Point to it, like put your finger on it. Start at Zadie and go around. Carla, you're not just checking, you're pointing to it so that they see it. Okay? Now the back row, the back row, the back row. Thank you, Carla. How did you know that that was so important? That was probably where you needed to look.
Because we said it once.
Louder so we can hear.
Because when we was doing example 1, we was saying another way how we can do it.
Well, and what did we do to show that that was really important? And you remembered, oh, that's the important thing. I need to go back to it. What did we do to it?
We put a box and put stars beside
We put a
the
box and we put stars behind it, beside it. We didn't do that just to draw some fun stars. We did that so that you would remember, oh, that's really important information. I need to go back to it. So when I said, how do we know that whatever we do to the denominator, we also have to do to the numerator? And I said, how do you know? You should have been like, oh, that sentence that we had to put a box around and star. I think it said something like that. Let me go back to it and read it. That's why. That's how we know. But if you're just putting a box around it and putting stars around it and not really listening to why or remembering why, well, then you're just drawing stars, which doesn't help us. But if you know and you're listening and you're paying attention and you're not just copying what I do on the board, you're listening to what I tell you and then doing it, then you're like, oh, I remember that sentence. We put a box around it. We put stars next to it. It said something about a numerator and denominator and multiplying by the same number. That's why. Let me read it so I don't get it wrong. Okay, so we know whatever we do to the denominator, we must do to the numerator. So everybody, finger a pencil on example 2. Read in your head while I read out loud. Every period, we're going to imagine. Liliana has a container of dry beans. Okay, so I'm imagining this like plastic container, and inside of it are dry, uncooked beans. So they're not liquidy in a can. They're in like a plastic container and they're dry. The table shows the fraction of each type of bean. Okay, that tells me that this table will tell me how much of the container are black beans, how much of the container are kidney beans, how much of the container are garbanzo beans, and how much of the container are lima beans. Which type of bean shows a fraction that is equivalent to 3/10 of the container? If we look, this sentence says each fraction in the table has a denominator of 100. Do you agree? That means our container probably has 100 beans in it. How many of the beans are black beans? Class? 20.
20 of them.
How many of the beans are kidney beans?
10.
Out of the
10
100
beans.
beans, how many are garbanzo beans?
40.
Out of the
40.
100 beans, how many are lima beans?
30.
Okay,
30.
but our question doesn't say which fraction is equivalent to blank 100ths. It says which fraction is equivalent to blank tenths, or to 3/10 of the container. So what we can do is we can use multiplication or division to find which fraction is equivalent to 3/10. So we know that what times 10 equals 100? What times 10 equals 100? Kingston, 10 times 10. So let's write a fraction with a denominator of 10 in front of each one. And we know we're multiplying each of those denominators by 10. Whatever we do to the denominator, we also have to do to the, Aaron? Numerator. Now remember, we're not writing times 10 once, we're writing it times 10, we're writing it twice. So now we need to fill in the missing number. We have blank tenths times 10 equals 20 hundredths. So we know 10 times 10 equals 100. What times 10 equals 20? Blank times 10 equals 20. Class?
2.
2. So, the black beans are how many tenths of the container? Tell me the whole fraction. I know I said how many tenths, but tell me the whole fraction. Lena? 2 tenths. Does that match? Is that equal? No. So let's look at kidney beans. We know it's not black beans. Let's look at kidney beans. We know our denominator times 10 is 100. Now we have to figure out our numerator. Blank times 10 equals 10. Zadie.
1 times
1. So kidney beans are
1/10
of the container. Nope. What about garbanzo beans? We know 10 times 10 equals 100. Well, what times 10 equals 40? Michaela? 4. So garbanzo beans are
4/10
of the
of the 3
of the 3/10
of the container.
of the container. Is that equal? No. So what about lima beans? We know our denominator 10 times 10 equals 100. So for our numerator, blank times 10 equals 3. Come on, boys, you gotta. You're not showing me that you're willing to work. Blank times 10 equals 30. Fill in the blank. Kingston? 3. So lima beans are 3/10 of. Were you listening when 1, 2, 3 people answered before? So that you knew what to say? 3/10 of the. Okay, I'm getting really frustrated with this side of the room because you're not even trying most of the time. Occasionally you do, but most of the time you don't. You let this side of the room answer. And you need to show me that you guys can do math just as well as the other side. Don't act like you're doing something else, and that's why you can't answer. Because if that happens every time, I know that it's not. You're just using an excuse. So can somebody tell Kingston what 3 people before him have said? The pattern that he should have been listening to follow so that we could have been done with this problem and moved on to the guided practice Because remember, answering questions in independent practice is a pattern. And if you're listening to what people say before you, then you know you're going to say the same thing other than one little part. So instead of saying 2/10 of the container, like who did? Lena? And instead of saying 1/10 of the container, like Zadie did, and instead of saying 4/10 of the container, like Michaela did, you are going to say, I can't hear you. I cannot hear you. You did not get any louder. 3/10 of the container. Is that equal to what the question is asking us? Sorry, can't.
Yes.
Yes. So, which type of bean shows a fraction that is equivalent to 3/10 of the container? Class. Lima beans. Now, another way we could have done this is we knew we were finding something that was equivalent to 3/10. And we knew we were looking for an answer that had a denominator of 100. See, people not writing. We knew the question was asking for something that was 3/10, and we knew our table gave us denominators of 100. So then we thought, okay, what do we do to 10 to get 100? Well, we multiply it by 10. Whatever do we do to the denominator, we also have to do to the numerator. So 3 times 10 equals 30. And then we would find 30 hundredths on our table. It's not black beans. It's not kidney beans. It's not garbanzo beans. It's lima beans. So you can either do it, you can do it either way. You could have also done this. What could I have divided? What did I need to divide? Carla?
2 and 10.
Can I do that?
Yes. I mean, no.
Why?
Because.
Zadie, can you tell her why?
Yes, because you multiply the numerator and the denominator by the same number.
So if I multiply the numerator and the denominator by the same number, I also have to
Divide the numerator and the denominator by the same number.
I either have to multiply the numerator and the denominator by the same number or divide the numerator and denominator by the same number. Are these the same number, Carla?
No.
So can I do that?
No.
No. And also if I did this, 100 divided by 10, oops, I messed up, is 10. 20 divided by 2 is 10. 10/10 is equal to what? We did a whole lesson on this. 10/10 is equal to what?
1 whole.
Is 1 whole equal to any of these?
No.
No. So, just like whatever we multiply the numerator, just like how we have to multiply the numerator and denominator by the same number, we also have to divide the numerator and the denominator by the same number. So, what could we divide? Come on, guys, it's a basic fact. It's a basic division fact. Basic division facts are just multiplication facts, but backwards. Come on. Michaela. 10 divided by 10? 10 divided by 10 equals 1. Come on, guys. Blank divided by blank equals blank. Blank times blank equals blank. It's backwards. Cullen.
100 divided by 10 and 20 divided by 10.
Divide by 10. Come on, it's a basic fact. 10 times 10 is 100. Is that a basic fact?
Yes.
100 divided by 10 equals 10. Is that a basic fact?
Yes.
Yes. So, 20 divided by 10 is?
2.
Did we get the same thing?
Yes.
Did we get the same equivalent fractions? 2 tenths, each multiplied by 10 is 20 hundredths. 20 hundredths, each divided by 10 is 2 tenths. It's the same thing, just the backwards basic fact. Division has basic
Right,
fact. So for the guided practice, it says, write the fraction for the part that is shaded. Then find an equivalent fraction. So what we have to do is we have to look at the shape, figure out what fraction shows that it's shaded. Then we have to show our work to show how we found the equivalent fraction, and then of course show the answer so that we know what the equivalent fraction is. So number 1, Kingston, we have this shape. It's broken into how many pieces? 4. Is 4 going to be our numerator or our denominator? Our denominator. The denominator tells how many pieces is the whole broken into. This whole shape, this octagon, is broken into 1, 2, 3, 4 pieces. Now the numerator, how many of these pieces are shaded? 2. So 2 out of the 4 pieces are shaded, which means what fraction is shaded, Kingston?
2.
What fraction is shaded?
2 4.
2/4. Now we need to find an equivalent fraction. You may choose to multiply or divide. You may choose any number as long as you do the same thing to the numerator and the denominator. So would you like to multiply or divide to find your equivalent fraction? Multiply. So we're going to multiply the numerator and the denominator, each by the same thing. Do not write. Kingston, what number would you like to multiply each of them by? Let's pick something that we can use a basic fact. Or at least basic facts and patterns. Quick.
12.
12. This is not the same thing. This is not the same thing. This is not how we write it. If I see you writing 2/4 times 12 equals whatever, I'm going to count you off because 2/4 times 12 does not equal whatever this equals. 2/4 means you take, these pieces and you repeat this 12 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is a piece this long going to be equivalent to this? No. Definitely not. So, that's why you need to show the numerator and the denominator each multiplied by the same thing. So Kingston, if we multiply our numerator, 2 times 12 equals 24. 4 times 12 equals 48. So 2/4 is equivalent to, how do we say that fraction? Guys, listen, I'm going to say it again. I hope that you will listen. You say the numerator, normally, 24. You say the denominator, exactly what it is, but you add to the end. So you don't say 24/48. You don't say 24 and then struggle with what to say here. You say 24/48. So Kingston, what is this fraction? 2/4 is equivalent to 24/48. If you need to do that so that we can all clearly hear you, sure, go ahead. You have a mask on, and I'm 6 feet away from you. Okay, next, number 2. We have our circle. Victoria, it's broken into how many pieces? 3 pieces. So is that our numerator or our denominator? Our denominator. How many pieces are shaded? 1. So that's our numerator or our denominator, or do we put it like somewhere else? It's our numerator. Okay, now we're going to use multiplication or division. Which one would you like to use? There's one that's not possible to use. Multiplication. We cannot use division here because that means the only thing we could divide by would be 1, which would equal 1/3. Are 1/3 and 1/3 equivalent, or are they the same exact fraction? Carla,
Same fraction.
they're the same fraction. Is same fraction the same as equivalent fraction? No. That would be too easy. That means for every single one you could write, well, 2/4 divided by 1 equals 2/4. 1/3 each divided by 1 equals 1/3. So what else? What can you not multiply by? Using that same line of thinking, what can you not multiply by? Smith. 1. So Victoria is going to multiply because we can't divide. What would you like to do? If you are choosing division, you need to use basic facts. If you are choosing division, you need to use basic facts. Otherwise, you might get a remainder, and that won't work. So, what would you like to multiply by? 4. Sure, that's fine. That's basically what you're doing. Unless it's asking you, are these 2 fractions equivalent? If it's just saying, find an equivalent fraction for this one, you can multiply by anything you want. Just try to use basic facts so that we can get through it quickly. Okay, the numerator, 1 times 4.
4.
Denominator, 3 times 4.
12.
So 1/3 is equivalent to 4/12. Look at the independent practice. Numbers 4 through 6 are exactly the same. So while I get the projector ready to model how to do 7 through 12 and 13 through 15, go ahead and start working on 3 through 6. You're doing the exact same thing. Be careful. Make sure you're choosing basic facts. And go ahead. Pause. You can finish your fraction if you were in the middle of it. And then look at number 7. Put your finger on number 7 when you're done, so I know that I can go ahead. Put your finger or your pencil on number 7, so that I know that you're finished with the one problem you were on, not all 4. Make sure that you're not trying to do all 4 because you're making everybody else wait who is following directions. Okay. So for problems like number 7, what you have to do is you need to take each one and see if you can multiply or divide to get that next one. So what we're going to do is we're going to start with the smallest numerator, 1/4. Actually, we're going to start with the biggest. No, let's start with the smallest. And we want to see, is it equal to 3/12? So we want to see, can we multiply this numerator and the denominator each by the same number to get this fraction, 3/12? Carla, is there something we can multiply our numerator and our denominator each by to get 3/12? So is there something we can multiply 1 by to get 3? And can we use that same number to multiply our denominator and get 12?
Yes.
Yes, because 1 times what equals 3?
3.
Is 4 times 3 12, Carla?
4 times 3 equals 12.
So is 1/4 and 3/12, are they equivalent?
Yes.
So we'll go ahead and circle those. But we also need to check, is 2/6 also equivalent? Is there anything we can multiply? So if we multiply 1 times what? Okay, 1 times what will give us 2, Carla?
1 times 2 equals 2.
Is 4 times 2/6?
No.
No. So that means 1/4 and 2/6 are not equivalent. But we still need to see our 2/6 and 3/12. So let's start with the smaller numerator. And see if it's equivalent to the fraction with the larger numerator. Carla, is there anything we can multiply 2 by to get 3?
No.
No. So that means it's not equivalent. Let's try the same thing with number 8. And then we'll do number 13. And then you'll just keep going. So let's try number 8 because I think we need a little more practice with that because you can't just find the first ones and then say, I'm done. Because what if all 3 are equivalent? So you have to test them all. Number 8, Lena. Let's start with the fraction with the smallest numerator and denominator, which is what? 2/10. Now, let's test to see if 2/10 is equivalent to 2/100. What can we multiply 2 by anything to get 2? Is 2 times something 2? Okay. Is 10 times 1 100?
No.
So are those two fractions equivalent? No. Let's try 2/10 and 20/100. Can we multiply 2 by anything to get 20, Lena? Think about it. You can use patterns here. But also think about your basic facts. What?
2 times 10.
So we can multiply 2 times 10 to get 20. Is 10 times 10 100?
Yes.
So are those fractions equivalent?
Yes.
Yes. But now we need to quickly test 2/100 and 20/100. So let's start with the fraction with the smaller numerator and or denominator, which is what? 2/100. Is it equivalent to 20/100? Can we do something? 2 times what equals 20? Is there anything we can multiply 2 by to get 20?
10.
Is 100 times 10 100? No. So is 2/100 equivalent to anything? No. So you're going to do the rest of them that way. You just need to test them. Start with the fraction with the smaller numerator and denominator. Or if one's the same, if they're all the same, whatever. Then test it with the others. Yes, Aaron, quickly. No, you can do it here, but you need to do it small. Actually, yes, I want you to use a separate sheet of paper for your testing. So you will use a separate sheet of paper. No, you can do it here, but you need to do it small. I've decided. Okay, now let's look at how to do number 13. The directions say find each unknown. This is telling us that these will be equivalent fractions. We just have to fill in the blanks. So what we're going to do is we're going to find what we know. We know the denominator of both numbers, right? So we're going to figure out what can we multiply 4 by to get 8. Mason, 4 times what equals 8? 2. Are we going to multiply our numerator by something different? No. So we're also going to take 1 and multiply it by 2. 1 times 2 is?
2.
So that means 1/4 is equivalent to
2 8.
2/8. That's all you do there. This is telling you they are equivalent. You're not testing like here. They are equivalent. You need to show this. And look at the guided practice. Look how, when I wrote it on the board, I wrote the first fraction, and then I showed times blank, and then I wrote equals the second fraction. Do you see that? That means every single one must look like that. I must see what you multiplied or divided by. I need to see it. Do you write it like this? No. You write it twice, once next to the numerator, once next to the denominator. For these, I need to see what you multiplied by. For these, I need to see your testing. Does everybody understand? Okay. Look at the back of the independent practice. These are word problems. They are like example 2 or example 1, where they are giving you the information you need to figure out what the first fraction is. So step 1, you figure out what the first fraction is. What is the fraction the problem is telling you? Then you need to figure out an equivalent fraction. So first you have to figure out, what is the word problem telling me? What is my first fraction? It's not going to say it's 3/10 like example 2. You have to figure it out, but it's going to give you the total number of objects, the denominator, and it's going to tell you how many out of that denominator you're working with. Then you have to show this to show me what the equivalent fraction is. So first you write the fraction the problem is telling you. Then you write what you multiplied or divided by, twice, once next to the numerator, once next to the denominator, and then you write the answer. If you do not do that, you will lose 2 to 10 points on your homework, which can bring you from an A to a C, or a B to a D, or a C to an F. So don't let not showing work be what causes you to fail. But read closely so that you don't fail even with showing work. So does everybody understand how to show your work on this lesson? You do not need a separate sheet of paper because you can show this right there on the paper, like we did with the guided practice. Number 10 is critical thinking with numbers. Number 20 is critical thinking with words. Look at your homework. You will have another piece, but it follows the same. You'll have a step, I'll print one out, but it looks basically the same. The word problems are just worded a little differently. Numbers 1 and 2 on the front and 3 and 4 on the back are just like the first part of the independent practice. Numbers 5, 6, and 7, you're just writing your own. That means, is there a specific number you have to multiply or divide by? No, you get to pick, but show all of this. And then numbers 8 through 10 are just like 13 through 15. You need to show all of this. And then number 11 and 12 are just like the word problems on your independent practice. You need to figure out what the first fraction is based on what it's telling you. And then you need to find 2 equivalent fractions. So that means you're going to write the first fraction, what you multiplied or divided by, and the equivalent fraction. And then you're going to write the first fraction again, what you multiplied or divided by, and then the equivalent fraction. Because the word problems on your homework, you have to do 2 equivalent fractions. So you just have to show that multiplication or division twice. Does everybody understand what I mean by that? You can show all of that on your paper, but do not forget units. So like number 11 is about bananas. So you're writing this fraction are bananas. Does everybody understand? Then number 13 is multiple choice. You need to show your testing. It's kind of like this, where you're taking the fraction the problem is giving you and testing it to see if it's equivalent to each of those fractions. So I better see 4 tests. Does everybody understand? It gives you the fraction 4/12. I need to see where you test it to see if it goes with 1/9. Sometimes you may have to divide. So if you start with 4/12 and you're trying to figure out if it's equivalent to 1/9. Well, can you multiply 4 by anything to get 1? But what can you divide 4 by to get 1? Cullen? 4. 4 divided by 4 is 1. That should be easy, but I only saw like 3 hands. Is 12 divided by 4 9? Class?
No.
No, definitely not. So is 1/9 equivalent to 4/12? Nope. So there's how you know, eliminate that choice. And do that every time with either multiplication or division. If the one you're testing, the numerator and the denominator are smaller than the one you start with, then you have to figure out, okay, what can I divide this by? Does everybody understand? I better see 4 tests for that homework on number 13. Any questions? If you are ready and you have no questions, go ahead. With your independent practice, you may do the first 2 on the homework. Pay attention. Is it asking, look, pay attention to all these problems. Is it asking for 1 equivalent fraction or 2? Because if it's asking for 2 and you only put 1, you're going to lose the whole point. Kingston, what's your question?